Okay, some of you, I'm not sure if the applied stream does this, but the academic stream, you definitely would have been exposed to this. We're going to talk about functions and not a function. And we're also going to be talking about domain and range today as we get into our introduction into quadratics that we're going to start with. So that's kind of where we're going with this. Um, I'm going to put up a question on the board, and I want you to, in your partners, to go over this. Nick? Okay, you don't need markers for this right away. Okay? So I have here, it says, given, so for those of you who drive cars, I don't know anything about cars, given the model of a car, i.e. a Civic, can you determine the make of a car, i.e. a Honda? Is this the only possible answer? I want you to talk about that with your partner. So it says, given the model of a car, a Civic, can you determine the make of the car? What is it? Is there any other options? Okay. What about this one? What? So there's only one, you're saying there's only one possible answer for that one, right? What happens if I did it the other way? Given the make of a car, i.e. a Honda, can you determine the model of the car? I.e. a Civic. Is this the only possible answer? So if I said the car is a Honda, would you know what it is? No, why? What do you mean? I'm talking in general. If I said I owned a Honda, you're sitting there, okay, well, how many Hondas are there? Pardon? No, 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 no. I say, what kind of car do you drive? I drive a Honda. Oh, okay. That's good. Yeah, there's lots of different models of that. Using this analogy, this is kind of how we're going to define functions. Being given something specific, like a Civic, are we able to tell it's a Honda? Or if I'm given a Honda, can I pull out something specific? So there's different representations that we can have when we're talking about functions. I have examples and non-examples. I'm going to show you what they are. Nope, I know it's not on the sheet. Given these examples, I want you to see if you can determine, so this is an example, these are all examples of a function. So I have numbers, I have words. Okay? Now I'm going to show you the non-examples. With your partner, I want you to see if you can come up with a rule for this. Based on this mapping notation, so this is what mapping notation looks like. A Civic maps to a Honda, an Accord maps to a Honda, a Pilot maps to a Honda. Pardon? Okay, don't get caught up on it. There's a rule here. So I have -2 maps to 4, -1 maps to 1, 0 maps to 0, 1 maps to 1, 2 maps to 4. It's just this is another representation of like coordinate points. You can think of it as x, y. Okay, so I want you to look at this and I want you to see if there is a pattern that you can come up with to describe functions versus not functions. Okay? Okay, was anyone able to come up with what is the rule? How could I visually tell if an example belongs to a function or not a function? Jenny? Okay, so how would you, okay, that's right for the words. How would you describe that in numbers? Okay, how am I able to tell which one's a function, which one's not? Rob? If I were to look at the left side, a civic is used once, an accord is used once, a pilot is used once. A -2 is used once, a -1's used once, 0's used once, 1's used once, 2's used once. 21, 22, 45. If I look here, Honda is being used twice. If I look here, 4 is being used twice. If I look here, 21 is being used twice. So as Robbie said, the X part, again, if you were to think of this as an ordered pair, X is always on your left, Y is always on your right. X can only be used once, not twice. So I have here 4 examples, A, B, C, and D. With your partners, I want you to discuss, is it an example or a non-example? Go through each 4 of those and tell me which one you think. Where do they belong? Talk about it with your partners. Okay, where is A going? Is A an example or a non-example? It's an example. Every first term or every x coordinate only maps to one y. How about B? Is it an example or a non-example? It's an example. Every x goes to only one y. How about C? Because drink maps onto pop in water. How about D? Example or non-example? This is an example. Every first element maps to a second element. Okay? Going to the next one, I'm going to show you, we can also represent this with a table of values. I'm going to show you examples of a function and some non-examples. I want you to talk about this with your partner, about what a rule is for a function and not a function. Talk about it with your partners, come up with a rule. Okay, what was the rule that you could come up with here? How can I tell using a table of values that this is a function versus not a function? What could I do? What's the rule here? X values only used once, 21, 22, 45, -1, 0, 1, 2, -2, -1, 0, 1, 2. These ones I have duplicate X values. Duplicate X values, so those are not functions. Okay, again, going through here, Are they functions or non-functions? Are they an example or not an example? I want you to talk about it with your partners, and then I'm going to take it up. So go. Talk about it with your partners. I actually want to hear you talking. What do you think? Okay, what do we think? A, is it a function or not a function? It is an example of a function. How about B, is it a function or not a function? It is a function. The x values are only used once. What about C? I have a duplicate. What about D? It's a duplicate. Okay? I'm going to show you one more with a graph, and we'll see if you can, for some of you, remember this. Here are some examples of graphs where they are a function. Here are some graphs where they are not a function. What's the rule here? What would be the rule here? Nick? How are you able to see that visually? They're lined up. Good. There is a vertical line test. Oh, I'm glad it's like I taught you something. Okay, we have what's called a vertical line test that you can do, which visually when you see a graph, if you draw a vertical line and you move it, it should only hit the graph in one spot. If it only hits the graph in one spot, then it is a function. When an example comes here, if it hits the graph in two spots, it is not a function. Again, two spots, not a function. There's two spots, two spots. That means that an x value is being used more than once. So we have that vertical line test. Okay, what do you think about these ones? Function or not a function? Talk about it with your partners and then we'll take it up. Okay, what do we think about the first one? Function or not a function? It is a non-function. This one, function or not a function? Function or not a function? Function or not a function? Good. So there's three ways that you have to identify a function or not a function. So we're going to go to your note now, and we're going to fill this in. You don't have one. Okay, definition. So what is a function? You're going to want to write a little bit small. Oh, I have it up there already. Haha. I forgot I did it. Sorry, yeah, it is different. No, I like this one better. Just write it above it or beside it. Not a big deal. This one's shorter. Sure, you can figure it out, Zach. Where? Every function is a relation, but not all relations are functions. A function is a relationship in which no ordered pair has the same first element. Sorry. Zach, did you finish copying this down? Do you maybe want to copy the other side down, please? Okay, so a function is a relationship in which no ordered pair has the same first element. Okay, ordered pairs, just in case you forgot, are always written as x, y. Every function is a relation, but not all relations are functions. Okay, so every one of those that we looked at, there's some sort of relationship that occurs, but they just may not be a function. So rules, no x values can be duplicated. Okay, we saw that. We saw that in mapping. We saw that in your table of values, and we saw that through a graph. Y values can be duplicated, though. You can use the vertical line test to determine if a relation is a function. So that's one of the methods that we would use to figure that out. Okay, it's a nice easy test when we have a graph. So I'm just going to give you some examples for your notes here. If I were to have, again, you can make any example, -1, 0, 1, as long as you only have one x value mapping to one y value, you are okay. Similar here. Those are all examples of functions. I have one x value being mapped to a y value. I have one x value here that maps onto its each unique y value, and then here that passes the vertical line test for the graph. Some non-examples. I have two x values, so 2 is being mapped to 3, and then 2 is being mapped to 5 as well. So there's a duplicate there. Hmm? Okay, does anyone have any questions on whether or not to figure out if it's a relation or a function or not a function? Is that pretty clear? Okay, now we're going to get to the next part, which is domain and range. This gets a little bit technical, but I'm going to give you examples that you're going to refer to. So it says here, the dependent variable is said to be a function of the independent variable. Knowing the value of the independent variable allows you to predict the value of the dependent variable. That's just really talking about x, y. Zach, if you want to go to bed, you can leave this classroom. Okay? Otherwise, please pay attention. That's pretty rude. Okay, so I have independent, dependent variables. An independent variable is always represented by x. And then the word there we use to describe all the x values in a function is called the domain. And it says, is the set of all x's in the relation? It's the first coordinate. Your dependent variable, which you may see as y, or written like this, we're going to talk about this notation tomorrow, f of x is how we say that. And the range is the set of all y's in a relation. And that will always be your second coordinate. So you need to know the domain and the range. Domain is talking about x, which is your independent variable. Range is talking about your y, which is your dependent variable. So they kind of all mean one and the same. So I have here, for your first example, it says using reasoning to decide whether a relation is a function. For each of the following relations, determine the domain and range, whether or not it is a function. Okay, so the domain here is talking about all x values. All x values Hello? Yes, he is. Ben, you have a detention after school today. He knows. Okay. Okay. Um, okay, domain is all your x values, which is your first element. There's a specific way we're going to write this that you have to get used to. We're going to write it using set notation, which is squiggly brackets. It's saying a set. So what are all your x values? So I write here x, because domain is always referring to x. I have a tall line here. That line represents such that. Pardon? Like a horizontal or vertical line is such that. Such that. It's like x such that x is. It's just it's math language. Okay? So then you would go through, what are my x coordinates here? What are my domains? So I'm going to use my highlighter here. Okay. If I look, here are all my first elements, which are my domain. They are all what? 0. So I just write this, 0. End squiggly bracket. Yes, we're going to talk about that. Okay, then I have here my range. My range is all y values. So I highlight them. I'm going to set up the range the same way. It's a set, so squiggly bracket. Range is always talking about y, such that the values for y are what I highlighted blue. What are the values that I'm going to put down here? -2, -1, 0, 5, and squiggly bracket. Pardon? They represent the set. So it says the set of y such that y is -2, -1, 0, and 5. Zach? If you just do a little wave, I'll know what you mean if you can't do a squiggly. Okay? Now, is this a function or not a function? It's not a function. Again, if you wanted to see this, it has, if I were to draw this in mapping notation, 0 would occur here. On this side, I would have -2, -1, 5, 0 and 5. And if I look, 0 is being mapped to all of these. So it's not a function. You're going to tell me whether it's a function or not. Yeah, because that's what it's asking. Nathan? Yes. Not for this. I'll get to it. Okay. Again, here I want to find the domain and range. If I'm color coding this, what color? I used yellow and blue. Okay, domain, again, is my yellow, which are all my x values. Range, which I've highlighted as blue, are all my y values. So again, I'm going to use set notation here. The set of y such that y is, or sorry, x, thank you. What would I fill in there? What would I fill in that set? Nick? Excellent. What about my range? What will I write here for range? What do I write? Such that. Okay, so that's my range. The set of y such that y is -3, 1, 5, and 9. Anyone have any questions with this so far? Are you good, Austin? Okay. Oh, is this a function? Is it a function? Why? Why is this a function? The x's don't duplicate. One x coordinate maps to its own unique y. Ooh. Okay, my domain here. Now we're going to be looking at graphs. Graphs become a little bit more complex, but this one should be pretty easy. My domain. Again, my domain are all my x's. So if I look here, because this is my x-axis, I have a value here, I have a value here, and I have a value here. I'm just looking at my x-coordinate. I could write them out in coordinates. So I could write this out as 1, 2. Then I have 1, 5. Nope. 2, 3, or in 3, 4. So when I'm writing this, again, the set of x such that x is, what would I fill in for my domain? Nick? DRM? Pardon? 1, 2, 3. No, you don't have to put duplicates. Yes? Nick? No. Okay. My y's, again, are my range. Where does the y occur? It's this axis here. I have a y point here, 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 and here. So it kind of goes from here, my lowest point, to my highest point. Y such that y is what? What would I fill in here? Austin? Good. Anyone have any questions about this? Is this a function? Yes or no? Is it a function? Why not? Very good. 1 is used twice. If you were to draw your vertical line, it does not pass your vertical line test. It crosses it twice. So it's not a function. Questions with this? Okay. For each relation, determine the domain and range. So I've done table of values. I've done a graph. X such that, what would I fill in here? Good. Domain is my first element. Okay, what about my range here? What about my range? Nick? Okay, is this a function or not a function? How do you know that, Nick? Okay, so anyway, what is it? Good. Okay. Domain. X such that. What is my domain here? Yes? Jetta? Beetle? Nope. Jelly, butter, like I don't know what those mean. So my range would then be what? Y such that Y is a Volkswagen. Okay, is this a function or not a function? How many of you think this is a function? How many of you think it's not a function? There's only one first element that maps to a y. Remember, you can have the same y, you just can't have the same x. So yes, this is a function. Okay, my domain here, I have x such that x is what? What do I put in here for my domain? I would put 1, 2, 3. Gentlemen? Y such that Y, Nick Danny Ram, can you tell me what I'm going to put in here? Maybe if you weren't talking, you would understand. 4 and 5. Is this a function or not a function? It's not a function. How do I know that? 2 maps to 4, 2 maps to 5, that's a double. Okay, I'm going to skip over some of these examples because they're the same. I'm going to go right to the graphing one because, yes. This one here, the Volkswagen, you want to go back to? Okay, if I look here, the first element is mapped to one unique Y. So a Jetta is a Volkswagen, a Beetle is a Volkswagen, a Passat is a Volkswagen. If I go to the next one here, 1 is mapped to 4. 2 is mapped to 4, but 2 is also mapped to 5. That's not unique. Okay? So because it's not unique, because it has that double line going there, it's not a function. Okay. My domain here, this is where it gets a little bit tricky. Connecting functions with graphs, determine the domain and range using real numbers. Okay, real numbers here. When we're talking about a graph, we're not just talking about 4, 5, 6, 7, 8, 9, 10. We're talking about everything in between because there is a line that connects them. So that includes decimal numbers. And when we're talking about using real numbers, there are imaginary numbers, which we won't get to. What that's saying is that it's including all decimals. They're imaginary numbers. Square root of a negative number is not a real number. Okay, so when we say using real numbers, we're talking about it's including everything. It's encompassing everything. So when I have here, I'm still going to use this same set notation, x such that x is. Now, I would be writing this set forever. It includes 2, 2.1, 2.11, 2.12. Like, it includes everything. So instead, because the line's connected, it's everything from, so if I'm looking at my domain, it starts here and it ends, starts here and it ends right here. So those are all of my values in the domain. So that's saying 2.877777765. Instead of writing that out each time, there's a notation that we use. What is my lowest value of x? So I'm going to write 2. What is my highest value of x? 10. Okay, now there's going to be some, I'm going to put it on there. It will typically be the same. We're talking about x. There's a special way that we read this. I'm going to read this to you so that you understand what it means. It's okay. It's a rounded E. Okay, so what this is saying is x such that x, this is how we read it. When I start here at x, I'm going to look to the left. So x, it has to be greater than or equal to 2. Greater than or equal to 2 because 2 is my lowest point. Then if I read it from the right, x has to be less than or equal to 10 because 10 is my highest point. Then this comma here is saying an element of the real, which means it includes all decimals. So I don't have to write 1.1, or sorry, 2.1, 2.2, 2.3. I don't have to write that. That's including all the decimals. So it's including everything in between. So again, here I have my lowest, I have my highest, and then just saying that it includes everything in between. Is an element of the real numbers. Yeah. No. Nope. Okay, range. Range will be similar. Y such that y, again, if I look here, my lowest value of y starts here, and it goes up to here, and it touches all y points. So what's my lowest y value? 1. What's my highest y value? 5. So instead of writing x here, I'll write y, and it includes all real numbers. Jenny? It should typically go in order. Okay, so again here, this is saying my lowest value is, so if I read this, the set of y such that y has to be greater than or equal to 1, because that's my lowest value. Y also has to be less than or equal to 5, because that's my highest value, and it includes all numbers in between, so it's an element of real numbers. Yeah. Okay, is this a function? Anyone know what the open dot means versus the closed dot? I think that's what arrows mean. Okay, this actually is a function. Because this is an open dot, it doesn't actually belong there. No. So if I were to read this explanation, whoops, pull this out, it says this relation is a function since it passes the vertical line test. The open dot, you don't have to copy this down as long as you know it. The open dot at the point 43 means that y, this symbol means does not equal 3. And the closed dot on 4, 5 means that y equals 5. So when when x equals 4, there's only one y value. So open dot means it does not equal. Closed dot means it is equal to. So again, this passes the vertical line test because this is saying it's not equal to 4 there. Or sorry, 3 there. Okay, so open and closed do mean something when you see this. Any questions? Austin? What do you mean? Okay, I'm going to go on to another one. Okay, my domain. My domain is my x values. My lowest x value is here, and it runs all the way through to here. It doesn't stop. It jumps a bit in the y, but it's pretty continuous. So again, I would write here, x such that, what's my lowest value of x here? 2. My highest value of x is 10. Then I fill in this. There's a reason why I'm doing it like this. Yep. Okay, so again, this is saying the set of x such that x must be greater than or equal to 2, less than or equal to 10, and is an element of all real numbers. So it means it's including all of these decimals in between 2 and 10. My range is a little bit different. Why? Such that, what is my range here? What would I put for my range here, Robbie? Okay, no. I don't use that because it does not include, there's no y values in between here. There's no y values there. So the only y values that exist are 2.5 and 4.5. Well, there's no y values that are in between here. So I only have a y that goes here and here. There's nothing in between there, which is why I only have two y values. X's are a little bit different because x is a continuous, it goes on, but it jumps, it goes right from 2.5 right up to 4. Is this a relation? Or a function, I'm sorry. Bah. This is not a function. This relation fails the vertical line test. If I were to draw it, it connects here. Those are both close dots. So that means there are two y coordinates, or sorry, two x values. So it's not a function. Austin? Yep. Which is essentially saying it doesn't pass the vertical line test. Okay, any questions with this? Okay, my domain. Here's my lowest value. Here's my highest value. It's a line, so it counts everything. So I have here the domain x such that pardon? Because I'm saying that x is an element of the real. Have I not been doing that? Shoot. You're supposed to be doing that. Write that down. So I should have had here x is an element of the real. Hey. Yeah, go in the back, sweetie. X is an element of the real. Y is an element of the real. I apologize. Okay. My range. Can I have someone who wants to try? What do you think I'll write for the range here? Not you, Robbie. Danny Ram, you're up. Less than or equal to? What is it? Element of the real. So the set of y such that y is greater than or equal to 1, less than or equal to 8.5, where y is an element of the real. Okay, that's it.